We're down here. I just want to talk to you about the projects 101 and probably 221. We'll see how this goes. All right, so 101, if you go here, you're doing project. First project is 41, get a Windows machine running. It doesn't even have to have all the tools installed. This one's easiest, but any Windows machine will do. You could just install the tools you need for each project. And then we're going to do the basic static techniques and then the basic dynamic analysis. That's my plan. So the basic static techniques is 101. And maybe I'll just try to open it in my virtual machine. That's probably the easiest way to do it. So here's my virtual Windows machine with no antivirus and such. So I can open up Firefox in here. Whoops. All right. All right. And go to samsclass.info. Right there. Good. All right. And now 26 projects and 101. All right. So the first thing here is VirusTotal. Like I say, we should really look at VirusTotal. It's more fun than it used to be. So we're going to look at labo101.dil in VirusTotal. So let me just open this in another tab. All right, this will do. All right. Now I can choose the file here, or I can drag and drop. Maybe I'll try it this way. It might be easier. It's on my desktop. Is the Malware Analysis Labs binary, Chapter 1, and labo101.dil is there. Okay, there we are. And so, as you see, it's red. Everybody detects this as malicious because, of course, this book has been around for years and everybody's been uploading a sample. So this tells me the names of all the antivirus engines that think it's evil and what they think. They think it's a Trojan or something. And there's a bunch that don't detect it, several smart ones, which probably are because they realize it's from the book and they know it's not really evil. And on some of these samples, yeah, here we are. That's detection. Now we can go to details, and details give you the hash of it and other information, what type of file it is. It's a portable, executable 32-bit code. And the creation time was 2010. Here's the names of it. Here's what compiler was used, Visual Studio 98 to make it, target machine, and that sort of thing. Here's the basic sections: text, RData, data, and relocation. Here's how big they are and the hash of each section. So that's somewhat helpful. And here it gives you the imports: kernel 32, MSV, CRT, and Windows 232. And you can see what library functions it uses. And this is the same thing you see by looking at the headers. There's all the library functions. This thing does networking. It does connect to a socket, close socket, receive, send. So it has networking features, and you can look in here and see what other libraries it uses. So that's the same stuff you'd get by looking at the headers, which we're going to do. Here's relations. It's related to other things, and it's, of course, related to other things in the textbook. This is just, I think, users have reported it as being related to other things. But behavior is the part I was talking about, which is very nice. It will show you sandboxed information. Here's the processes it loads. And different files give you different sandbox options. Download artifacts, full report. Looks like the only one I get here is C2AE, and it looks like it's not as helpful as some of them. Some of them actually give you 2 or 3 sandboxes, and they let you see everything it did step by step. This one here, they do show processes and service actions, but not much more. And didn't do network communications, probably because it's a library and not an executable, so it really couldn't run it very effectively and get it to do things. But anyway, as I say, VirusTotal now has a whole lot more information than it used to have, including a lot of what we're going to do here manually. So, I'll go back if I can. The thing is...
So what is this project supposed to have us do with that?
Oh, you just send it to VirusTotal, and in the book you just look at it to see if it's detected. But like I say, now you can do more. So the first thing is just send it to VirusTotal and see what happens. Get used to that. That's an option. The only one thing about VirusTotal, though, is that it can reveal that you have found the file. So that's why be aware of that. If you have found malware that a bad guy's put on your network and you don't want to tip them off, then don't use VirusTotal. Or don't use it that way. If you upload a sample, it remembers it's up there. Anybody else can see the results, and it tells the antivirus companies, so the bad guy knows you're onto them. So if you want to check in VirusTotal without uploading it, you can calculate the hash and search for the hash. And then you'll see if it's already known. But if it's not known, VirusTotal will not learn anything about the file. And that's what you want to do if you're trying to maintain operational security. Anyway, now to do the stuff that VirusTotal showed us some of this more manually, we can use PEView. And so let's do that, PEView. Yes. Yes. I hit the search box. I do seem to be having some lag problems.
The code may be occupy the whole screen.
I couldn't hear what you're saying. There's PEView. All right, now I can open that same thing, which is desktop, Malware Analysis Labs, binary. It's not too bad, I just have to be a little patient. Oh, and I'm looking for a DIL, and there it is. Okay, so here you see the raw contents of the file in hexadecimal and ASCII. Every executable always starts with MZ, and it always has this message: this program cannot be run in DOS mode. Here's the real PE header coming, and below that will be more information. But here it's broken it up into useful pieces. So here I see the time date stamp when this thing was compiled. That's often useful. One thing antivirus companies do is they look at what time of day it was where it was made, and they decide what nation it's in based on when would that be normal part of the business day. You can tell American malware from Chinese malware from Russian malware to some extent that way. Here's the text. Yeah?
People can change their time, right?
They can, and you could also work at a strange time. So it's a weak indicator. It gives you some information, but you can't trust that kind of information. And you can, by the way, change the time anyway. You can change this timestamp. Here's the text section header that just tells you how big it is and such. And here's the header for the R data section, which is more of the same, and data and relocation. Here's the actual text section itself, which contains a bunch of assembly code, which is not readable. Here's the R data section, which contains your import address table. This is where you list all the libraries it uses and all the functions it's going to use. So you see it's going to load kernel 32, MSV, CRT, and WS232. And here's the functions it's going to use in there. Here it gives you the names like sleep, create, process. Down here, for some reason, it didn't fill in the real names. It just gave me some kind of numerical value, which is rude. It looks like a defect, perhaps of PEID or perhaps of this malware. Remember, the VirusTotal was able to find the functions we had down here, the networking functions. This tool is not finding them. All right, so that's the kind of thing you see in PEView. And there we are, that's what I want. All right, so there's a flag defined there just to show that you've got your PEView running. And there we are, it's scrolling down for me. I think if I use the keyboard, it might be a little better. We'll try that. Okay. All right. All right, so then we'll use PEID and see what it finds. So let me get rid of PEView. All right, I think the browser is really slowing me down here. I'm going to quit using the browser in the virtual machine for this one. I'm only going to need to use it for one more activity later. All right, let's close this window. All right. All right, now it's doing a little better. Seems like Firefox is what slows me down there. So let's run PEID. This is an old tool that uses a whole bunch of fingerprints to decide what language something was written in. So you can open a file here. There we go. It's going to be labo101.dil again. That'll do. And now it tells me this was written in Visual C++, a DIL. And I can see the sections here, text, data, R data, and relocation section, and how big they are. And that's the main thing. The main thing you use this for is just to see what language it was written in. So it was written in Microsoft Visual C++, which is what you'd expect. They use Microsoft tools like Visual Studio to write this. Now let me go to my host machine out here just to see the instructions. Somehow I'm not able to get out there. Okay, now I'm out there. All right, so 101, all right. Now bin text, the most fun tool. Let's play with that, and that's why I've got my machine set to be big so we can see it, because bin text has kind of small font. So bin, all right, there it is. I put it on the desktop. Oh, let's close PEID. All right, here's bin text. I think. All right. That's because I turned on a compatibility mode. Okay, here we are. So, by the way, let me see if we're supposed to do the EXE or the DIL. DXE. Okay, this one you want me to use the DXE, I'll do that. Not that it really matters for this demonstration, but it'll matter when you're doing the project. Make sure you're opening the right file. Otherwise you won't find a flag, so there we are, we go. This just finds every readable string in the file. It's very simple, so it finds this, always this message about DOS mode. Here it finds the name of sections like text and data. Here's some names of Windows API calls, like close handle and unmap view of file. Here are some lower level Windows API calls with the underscores in front of them. And if you go down to the bottom, you'll see other strings. Now here's ones, I think we talked about this. This is where I see Windows System 32 Kearney 132.dil. That's a misleading name, so that strongly suggests it's the malware is going to create or use a file like that. This will destroy your machine and so on. So anyway, you can learn quite a bit about what it does this way. And by the way, here's some of these functions that was using from those libraries, suggesting it's going to do create file mapping, create file, find next file, find first file, copy file. This strongly suggests it's going to hunt through a directory looking for a file and then do something with that name. So probably it's going to look through a directory to see if that file is already there, Kearney 132, and if it's not there, it's going to create it. That's the sort of thing I would guess. I don't know that, but I'm guessing that from the name of the functions here. And if there was going to be an IP address or a URL, we might see that here too. Oh, I'm not seeing one. But that's because it's in the DIL. The networking's in the DIL. We saw that before. The EXE doesn't have networking in it.
So this is a really stripped down version of what the executable looks like. You're not really looking at individual assembler.
That's right. That's right. This is a very simple tool. It just looks for readable strings in the file. And so it can, some of them are just junk, just random strings that happen to be readable. But, and of course, it could have misleading things. And if you compressed it, you'd see just junk everywhere. So you don't really know what's going on. These are just the strings in there. Yeah. But most of the time, you can sort of get a clue what's happening. The other tools are much more precise. Like you look at the header, you find what libraries it's using. It's really using those libraries.
But the only reason why there are strings in there, those are embedded comments.
They're also names of modules. And they're also in the header, names of library functions. Yeah, the names of functions.
Assembler code, you're not using it at a high level.
Yeah, but if you can, for example, if I look for a file name, I would call the Windows routine find file, and the name of find file will be in there. It's a string used just the way it is. And if I compare it to a file name I'm looking for, the string I compare it to will be stored there, readable in the code. So you'll be able to read all the constants, and the string constants count too. So if you don't make some effort to prevent it, they'll see all the readable strings in your code, which will include, like if you say if password equals the top secret, let me in, you'll see the top secret there, unless you write code that hides it. All right, so then you can analyze lab and see some things. All right, and then there's some flags to find. Now there's another tool called Dependency Walker, which I don't love that much. I don't think I'll bother demonstrating it. But this one lets you see what functions are being used in libraries in another way. And the point of this is to find out if your executable needs a library that it can't find to fix bugs. I haven't found it to be all that useful for malware analysis. Seems to me like PE view gives me enough information to get by without it. So then there's some challenges here where you can just find various flags to get extra credit. So the first part, it totally tells you what to do, and you know just what you're looking for, and it has instructions, and that's all the normal stuff. And then there's extra credit parts where you can find more from about some of these files, just trying some of the tools you've seen to practice static analysis. So that's the first one. And let me stop this video. And I see there might have been some questions I missed. I've been distracted by getting my virtual machine working.